Okay, hello everyone. So I would like to welcome you again here. And in this work, we are with the name Probabilistic Fusion of Deictic gestures and language command and then benchmark dataset and baseline methods, which was done here with my dear colleague and also tutor Karla Štěpánová. So first I would like to introduce the problem, which is this paper about. You can imagine a situation like this, when you have a robot, user, some workspace, there are actually cups in this example, and you would like to make the robot move the cup on the left. So you say move the red cup, and you also show the space where actually cup should be. If you just say move the red cup and you're not showing to the robot where it is, robot actually cannot tell if it's the cup on the left or on the right. The same is with the gestures, because from the gestures, where they are really intuitive for us, we are showing to some object, but they are not so precise. So we have to merge them. By these situations, we're thinking, okay, are there any data sets which we can work with? And we discovered there are lots of data sets which are actually oriented into language and vision, but some of them are also into gestures, but they are, for example, missing some specialty which we needed, or you cannot actually change them a lot. So our contributions for this paper were first created a simulated data set by these situations when you have lots of ambiguous situations, when you cannot tell from simple language or from a single gesture what object you should actually take, and make it publicly for other people, and also evaluate 3 baseline approaches with the data set. So first, I would like to talk about dataset creation. I've been thinking how to make it. So we created 3 main components, which by them we can actually change, increase or decrease ambiguity in the dataset. So first, in scene complexity, you can imagine it as here is an example where, for example, scene complexity 0 is where all objects are totally the same. So if you are, say, pick up the red cube, all the objects are actually selected. Then we added some different property in the object, and we created scene complexity 1. It's where we added color. So then if you say again, pick up the red cube, actually half of the objects are selected. So the ambiguity of selection the object is lower. Then we added more properties, and we created in our dataset 4 different scene complexities. Then we have been thinking about language complexity or language structure, we can say. As you can see again in this example, when you can say pick up the cube or pick up the red cube. The difference is again that the ambiguity are different. So you can create your own structure of language. Then we have been thinking how we can actually simulate the pointing gesture, that we are pointing to something. We're thinking, okay, maybe we can select just some random point, and around the point that would be the objects, but we would like to create something like probability vectors of selecting the objects by the pointing gesture. So by a really basic method, we created bounding spheres around the objects. Then in the target object sphere, we selected a random point and created a line from simulated hand, which is some coordinates in a space. And if this line is actually intersecting some of the object bounding spheres, then the object is selected. And the other object, their probability of selection is computed by the distance from the line to the bounding spheres. By these 3 main components, we created a dataset, which I said before, it's publicly available. And there were 3 objects, cube, cylinder, and sphere. They have different properties like 4 colors, 2 sizes, 3 shapes. Then there are different command complexities where there's always action, and then there are optional parameters like color, size, object type, or object class. Then there were 4 scene complexities, as you can see before, and there are the scenes. How we saw the scene is that we have something which is called the general scene, which you can imagine it's a description of a scene. For example, there are 5 cubes. And then you have iteration of the scenes, which is the scene where the cubes have aligned positions. So you can create as many iterations as you want to. They are randomly generated in a space. And what's really great from my point of view is that you can on your own add your new parameters and new properties and new objects, so you can actually expand this data set and I can say there are definitely the limits, but you can expand. So now we can go to our purpose solution, which is object detection in the scene when we get the information like pointing gesture, then language input, which is describing the object. In this case, it's the red cup, and scene object properties. These three information goes into scene context merger, where there is matrices multiplying, and we are reducing probability of objects that are actually not in the scene. For example, if you would say pick up the red cube, but the red cube is not in the scene, in the current scene, the probability of selection would be suddenly lower. Then the main and important part in this detection is a general merging. It's general likelihood merger, where we tried 5 methods, and it's addition, multiplication, maximization, then weighted mixture of the previous ones which I mentioned, and also neural network. You can see an example here when from the scene context measure we get a matrix where our probabilities of selecting the cups, and after the neural network we get just one vector which is telling us with the highest probability which cup should be selected. So now at the end, let's go to the results which were given by the dataset and by our methods. We discovered that with increasing data complexities, actually all the methods like addition, which is here sum, or multiplication, which is mul, are decreasing. Meanwhile, newer methods, let's say, like neural networks, are getting better. That's all from me. If you have questions, let's talk about them. Thank you.
Thank you very much. Do we have questions from the audience?
Hi, thank you for presenting this exciting data set. I wanted to hear a little bit more about that process of how you're, I guess, like using vectors to. I'm curious, yeah, how you're using like vectors to represent pointing, and how that might relate to human deictic gestures. I think it's not always the case that like when we point, like there's a straight line from your finger to the object. Like kids will often like flex their finger back and they're like pointing up, rather than at the thing. So I'm wondering like how this compares to maybe human pointing.
Okay, so the point is we were actually not mainly thinking about the pointing, like how to recognize the gesture, but that the gesture was already recognized. So the main point of this was create somehow ambiguity in pointing somewhere.
I don't see another hand rise up. Okay. Yeah. With this, I would like to thank Michal. Thank you very much.
Thank you.